what is the current passing through each of the resistor in the diagram shown. You can see the diagram below is the kind of a question that is being asked. So first of all, let us try to apply the laws that we have learned, like Kirchhoff's voltage law and the Kirchhoff's current law, and try to solve the problem. So we need to see how does the current distribution happens. So current starts from the positive plate of the battery here. At the current started is I1. That I1 will come this way and comes back to the negative plate of the battery. This I1 is not going to go through this 3 ohms because there is another cell, assuming that all these cells are ideal cells, they don't have any internal resistance, who is driving the energy through it, charge through it. Therefore that I1 is not going to go that way. So from again 6 ohms, a current I2 starts. This will go this way and go into this, and that I2 will return back to the negative plate of the battery. So I1 will return back this way, I2 will return back this way, but across the middle resistance of 2 ohms, both that I1 and I2 are being passed, right? Now we need to calculate the current across each of the resistor. That means across 5 ohms means I have to calculate I1. Across 3 ohms means I have to calculate I2. But across 2 ohms means I have to calculate the sum of I1 and I2 because both of them are in the same direction, right? So to solve that, to do that, we shall apply the Kirchhoff's voltage law. We shall remember back what is Kirchhoff's voltage law is. We have discussed it in the previous video itself. I can leave the link in the description for that. Now the Kirchhoff voltage law, to apply that, we shall have a closed loop. Now if you call these points like A, B, C, D, A, B, C, D is a closed loop. Of course you can call these points like E and F. Then C, D, E, F is also a closed loop. Let's apply Kirchhoff's voltage law in the closed loops. For that we shall consider either a clockwise or an anti-clockwise direction. Let us consider a clockwise direction. This is what our clockwise direction is. As I told you, the only condition is if once we have chosen a clockwise direction for one part of the problem, for this other part of the problem also we shall choose clockwise direction. We shall not change the direction. That's the only rule. You can choose either clockwise or anti-clockwise. For both the loops I have chosen a clockwise, right? After choosing the clockwise, we shall remember back the rules. What are the rules is, if the current passing across any element is in the same direction that we have chosen, consider that potential drop as positive. Consider that potential drop as negative. So here I1 is passing through 5 ohms in this direction and the clockwise direction is also going in the same way. So potential drop across that is a negative. So what could be the equation I can write? Minus 5I1, right? I can write an equation like minus 5I1. Now that comes this way here to this resistor. So be careful that the current passing across this 2 ohms is not only I1, I2 also. So both of them are in a direction that is similar to the direction we have chosen. Therefore we shall consider that potential drop as a negative. So minus 2 times of I1 plus I2, and consider look at the battery. You are going this way, you are getting the negative plate of the battery first. That EMF is positive, right? Plus 12 is equal to 0. That's the first equation we can write, right? Okay, so by rearranging the terms, minus 5I1 minus 2i1 minus 2i2 plus 12 is equal to 0. Then minus 5i1 minus 2i1 minus 7i1 minus 2i2 plus 12 equal to 0. Therefore, taking these terms to the other side, 7i1 plus 2i2 equal to 12 is one equation. 7i1 plus 2i2 equal to 12. Let's apply this. We have applied for the loop ABCD loop. Let's apply the same for the other loop. What is the other loop is? Let's have a look at that. Applying Kirchhoff's voltage law in the other loop. This is the loop C, D, E, F. C, D, E, F. Let us start from the cell itself. So we have already chosen a direction, that is the clockwise direction, similar to the previous part. So this is what our clockwise direction is. And look at this resistor 2 ohms. In this, current is going this way, that is in downward direction, whereas clockwise direction is opposite to that. So if the direction is opposite, potential drop across them is positive. That means plus I1 plus I2 of resistance R, that is 2 ohms. Now come to this part of the problem. See here. Here the current is going in this way from the positive plate of the battery. The clockwise direction is again, see here, yeah, opposite direction. So that potential drop is also positive, that is plus I2 of resistance 3, right? And look at the battery. You are going this way in the clockwise direction. While you are going, first you are getting the positive plate of the battery and then the negative plate of the battery. In that case, EMF is negative, as we have explained in the earlier video. Minus 6 volts equal to 0. So let us simplify that. 2i1 plus 2i2 plus 3i2. Take the 6 to the other side, it becomes plus 6. So 2i1 plus 3i2 and 2i2 is 5i2 equal to 6 is equation number 2. Right, so second equation is 2i1 plus 5i2 equal to 6. So we have equation number 1 here, equation number 2 here, and there are two unknown terms I1 and I2, and we have two equations. So simply solving the two equations will give you the required answer. How do I solve it? To cancel I1, I can multiply equation number 1 with 2, and I can multiply equation number 2 with 7. Let's do that, right? So equation number 1 with 2. What happens if I multiply equation number 1 with numerical number 2? Here, equation number 1 with 2. If I do that, what happens? Let's do that. Yeah, 7 into 2, 14i1, 2 into 2, 4i2 equal to 2 into 12, 24. Similarly, equation number 2 multiplied by 7 with this factor. This is equation number 2. Yeah, what happens then? It's 7, right? So 2 into 7, 14i1, 2 into i2. Sorry, this one. This is the equation number, right? So with multiplying with 7, 7 into 5, 35i2 equal to 6 into 7, 42. So I got two equations. 14i1 plus 35i2 equal to 42. This is one equation. This is one equation. This is one more equation, right? Let me call this equation number as 3 and this equation number as 4. I can say now 3 minus 4. What happens if you make 3 minus 4? Let us try to do that. 3 minus 4. I am just moving the page little forward so that you will be able to see. Equation number 3 is 14I1 plus 4I2 equal to 24, and next equation is this one, 14I1 plus 35I2 equal to 42. I am subtracting, so minus, minus and minus. 14I1 minus 14I1 equal to 0. 4 minus 35 minus 31I2 equal to 24 minus 42. So 24 minus 42, that is minus 31I2 equal to minus 18. So I2 equal to minus minus gets cancels, 18 by 31, and that value is approximately 0.58. There is something like 5806 and so on, but for the calculation sake, let us consider it like only 0.58. Now I got the value of that I2. We have calculated the value of I2. I can substitute that this I2 in any of the equations that we have, right? So in which equation we'll try to substitute this I2. Let us substitute in equation number 2. You can substitute in any equation, but that equation number 2 looks like little simpler. So let me substitute in that, right? Therefore, substituting I2, that is this much, in equation number 2, that is this equation, right? Let us substitute. So what happens? Equation number 2 now transforms as 2I1 plus 5 times of I2 is 0.58 equal to 6. So 2I1, 5 8s are 40, 5 5s are 40, 5 5s are 25, and 4 29. So it becomes 2.9 equal to 6. So 2I1 is 6 minus 2.9, so it's approximately 3.1. So I1 will become 3.1 by 2, so that's approximately 1.55 amperes. So I got the values of both I1 and I2. So our basic aim of our problem is calculate the current passing through each resistor, right? So I already calculated I1 here. Yeah, I1 is the current passing through this. I have calculated. That is, value is nothing but approximately the value of the I1 is around 1.55 ampere. Current passing through 3 ohms I have already calculated as 0.58. Now the current passing through a third resistor, 2 ohms, has to be calculated. Current passing through that is these two summation, because they two are in the same direction. As they are in the same direction, we shall be adding up, right? So the current, that implies the last part of the problem, current passing through the middle resistor, that is 2 ohms, is I1 plus I2 of resistance 2. It was given like 2. So I1 value is 0.58, I2 is 1.55. So what happens to the value? 0.58 plus 1.55 of 2. So you can just add them up. 1.55, 0.58, that is 13, 11, 2.13, right? 2.13 multiplied by 2, so it's approximately 4.26 ampere. This is how we can solve the problem, and the whole idea of solving this problem is to make yourself familiar with the Kirchhoff's voltage law and its sign convention. That's how you have to solve the problem, right? Thank you for watching. See you again.